What's up everyone, welcome to part 2 of our Movidius Raspberry Pi deep learning tutorial series, and in this one we're going to look at how to take a model and its weights, compile it into a graph so then it could be ran on the Movidius Compute Stick using the SDK. So what you see here is a graph of YOLO, and we're running it on our compute stick through the VM. And we're getting about 4 frames per second, we're detecting both the bottles and the TV monitor, so that's pretty impressive. So in this video, we're going to look at how to set all this up. If all that stuff that I said earlier didn't make sense, it will all after this video. So let's get started. Now, before we jump into the code, I need to fill you guys in on some changes I made while offline. So there's actually 2 versions of NCSDK. There's version 1 and version 2. And what we installed in the previous video was version 2. But after searching online, nearly all the examples that I found were all written in version 1. And the thing is, version 2 is not backwards compatible. So you can see here, programs written with NCAPI version 1 will not compile or run with version 2. Now, with that being said, what I did was create a new virtual machine and I installed version 1 SDK. So all the setup for the VM and the install process is identical, so you can still refer to the previous video for all the setup instructions. The only difference is going to be which repo we clone. So if we jump over to the NCSDK GitHub page, you'll see that they've got 2 commands. So the first command is to clone the version 2 SDK, and the second one is to clone version 1. So in the previous video, this is the git command we ran, and you can see it installs or it clones version 2 SDK. But what we're going to do is create a new VM, and the repo that we're going to clone is this one here. So I've already gone ahead and created that new virtual machine and installed version 1 SDK. So you can see here in my VirtualBox menu, this Movidius 1, this is my new VM. So I cloned version 1 repo. I installed the version 1 SDK, so I ran make install and make examples, and everything's set up. So now I want to talk about graphs for a bit. And a graph is the file format of the model, which we can use to load onto the compute stick. So our model needs to be compiled into a graph, so then it can be loaded onto the compute stick and ran. And then we use the SDK to do that, so we can use those SDK commands to load the graph, to do inferences, things like that. But the main thing is we need to generate that graph. So the way we do that, well, at least for Caffe models, is the following. So let's say we're on our main computer and we're working on defining a model and we're training it, we're specifying the layers, tuning it, tweaking it, getting it to perform the way we want it to. Once we've got our model fully trained, we need to get 2 things. We need the pt.2 file, which is basically a text file that specifies the structure of the model. So it'll have all the layers, the input sizes, the number of layers, all those fine details that specify the overall structure of the model. So we need that, and then we also need a weights file. And we all know what weights files are. It's all those values of like the filter weights, the layer weights, all the biases, things like that. This is usually a pretty big file, maybe 100 to 200 megabytes. But we need those 2 files, the pt.2 file and the weights. Then what we can do is use this command mnvccompile. And what this does is takes the pt.2 file and the weights and compiles them into a graph. So a command would look like this. We'd say nnvccompile, then we'd specify the pt.2 file, then we do -w, specify the weights file, and then there's some extra stuff. Usually you'll see this -s and then 12. And then the output is going to be a graph. So now let me jump over to show you just an example of this in the SDK. So we're over here in the AlexNet example. So if you go to NCSDK, examples, Caffe, AlexNet, this is what you'll see here. So you'll see a bunch of files, but the main ones are going to be the pt.2 file and the weights file, which is this 0 weights -caffe or .caffe model. And so we can use those two files to generate the graph. So the graph is the thing that's fully compiled, and we're going to load that onto the compute stick and run it. So you can think of generating all this stuff like the weights and the proto.txt file. That'll be done on like our main computer with the GPU and all that stuff that we're going to do all the development. Then for the compilation, that's going to be our virtual machine. So we need Ubuntu 16, and we're just going to use that for compiling and maybe to test to run the model on the compute stick. So you've got main PC with your GPU, then you've got your virtual machine, which has the SDK just for compiling and generating those graphs. And then you've got your Raspberry Pi, where you can finally take this graph, load it onto the Raspberry Pi, plug in the compute stick, and run it. So now I just want to show you an example of generating the graph using a repo of YOLO that I found. So the repo I'm going to use as an example is going to be this one here, YOLO v2 NCS. So this was made using Caffe, and it's written with SDK version 1. But basically what we're going to do is we're going to clone the repo, we're going to compile the proto.txt file and weight file to generate our graph, and then we're going to use some code that they've already provided to run that graph on the compute stick. So to begin, I'm just going to copy the location here. Then let's open up a new terminal, make it a little bit bigger, and I'm just going to cd into my documents, and then I'm going to call git clone and paste the repo in. It might take a little time because it's got the weights file, so there's quite a bit of size to it, but once that's done, we'll take a look at the repo and show you all the stuff in it. So what I'm going to do is pull open my file explorer, go into documents. So this is the repo that we cloned. So now I'm going to go into models and Caffe models. So here you can see we've got a Caffe model and a proto.txt file. So this is the weights and this is the proto.txt file. Now what we're going to do is we're going to generate the graph. So the way we do that, we're just going to come down here. We're going to skip step 1 and we're going to jump to step 2. So we're going to call mvnc compile, specify that proto.txt file and the weights file to generate the graph. So here I'm just going to move into the directory or the repo, and then I'm going to run this command here. So I'll copy that, switch over, and let me just open this up so you can see. So we're in here, and now I'm going to run the command. Let's just move this down here so we can see the graph file be generated. So I'm just going to paste that in, run it, and there's our graph. So graph's ready, and we can actually use code that they've provided to run the graph. So now that we've got the graph generated, how do we actually run our model? Well, in order to do that, we have to write a script that's going to be using the NVSDK to load the graph onto the compute stick, do the inferences, all those things. It's really not that many lines of code, but we're not going to go over all those details in this video. We will look at it in later videos, but for now, we're just going to use the script that's provided with the repo. But for now, if you are interested in seeing those commands, how the SDK works, what I'd recommend doing is going to the NCSDK folder, go into the examples, check out the Caffe examples, pick one of these models like AlexNet, then open up this run.py file, and you'll see how they load the graph, allocate the graph, discover devices, all those things. It's really not that long, maybe 100 lines of code or so, but again, we're not going to go over it now. We'll cover that in later videos. So for now, what I want to do is show you how we can run the script that's provided with the repo. So I'm just going to go to the documents, YOLO v2 NCS, then I'm going to go to this detection example, and you'll see that there's these 4 files, main.py, objectWrapper.py, visualize.py, and then this shared object. So these 4 files make up the script that is used to run YOLO. So I've already got them open in Atom. So the main.py one, this is the one we're going to be running, and you can see they're using argparse, so we can specify the graph, the image, or a video file. So the only change that I made to this was down here, there's this elif statement, which means if you specify the video flag, that means it's going to run this portion. So it's going to load the video file, that's our cap device, and then it's going to loop through all the frames and display the boxes on it. Well, instead of video file, what I did was just put a 0 here. And what that's going to do is just read from our webcam. So now when I run this and I specify a video, it doesn't matter what I put, it's just going to run from the webcam. So normally this said video file, I just put a 0 there. So now what we can do is just run this command here from the main directory of the repo. We'll call python3./detection example main.py, and then I'm just going to do -- video and put something. So let's open up a terminal. I've already got it open in that main directory. So let's go ahead, bring this down here, and we're going to do python3./detection example. Then we're going to call main.py and then -- video, and then it doesn't matter what we put. So I'm just going to put a 0. Let's go ahead and run that, and we should get the feed from our webcam. All right, so let me just bring this over here. So now you can see we're detecting the bottle, we're detecting the TV monitor, and we're getting a little over 4 frames per second, 4.2, 4.3. Pretty not too bad. So yeah, this is it running in action. We did just kind of take their code and run it, but at least we're up and running. We've got the stick working on our computer. So I forgot to mention that, yeah, I've got the stick plugged in. You can see it's on because if I go to devices, USB, it's this one right there. But yeah, everything's working. Everything's working the way we expect. So that's good. So that's going to do it for this video. Sorry about the installing version 2 SDK and then having to go back and redo everything to install version 1. But if you've done it once, you can do it again, and the second time it'll be a lot faster. If you've got any questions, like always, leave them below. I'll do my best to answer them, but also feel free to join the Discord server. You can join, chat, ask questions, and probably get feedback from others who've worked on this stuff, so feel free to join that. Also, I provided links below to Amazon where you can get the Raspberry Pi and the Movidius Compute Stick. So feel free to use those links to purchase them. And yeah, so that's going to do it for this one. Thanks again. Talk to you guys later, and peace.